So I mean, this is a street in Canada, between the Canada and the United States. It's actually the border runs through the street. And on one side of the street, you have to pay Canadian dollars. On the other side of the street, you have to actually spend US dollars. So thanks to Bitcoin and the decentralization revolution, I mean, we're moving from dumb money with arbitrary borders to smart money, which is serving entire industries, right? Like with Bitcoin, Bitcoin or Ethereum or any of the other cryptocurrencies, you can pay anybody and power entire industries. So same thing is happening to computing as we know it. So if you look at the 5 stages of computing that we've gone through, we all started with decentralized computers, where computers were actually human beings sitting and making. Computers came from the term where human beings sat and made calculations with calculators, literally. From there, we went to a centralized mainframe. I'm pretty sure people remember COBOL mainframes where people terminaled into and did computation there. From there, we went to a decentralized client-server architecture where both the client and the server are powerful. So like the centralized mainframe happened because mainframes were powerful and the terminals were weak. And then we moved on to an architecture where we had both the client and server equally powerful and talked among themselves. From there, we transitioned into a cloud computing model because like companies started setting up large infrastructures in their data centers, taking in a lot of capex for compute that they did not need. So like even today, the data centers across the world are all built for peak capacity and not for average capacity. And when you build something for peak capacity, it means that you're hardly utilizing 30% of the data center at any point of time. So from there, we moved to cloud computing where people realize, okay, it's much better to provide computing at a centralized location and then rent out only the amount of compute that you need. And this model is right now the most viral model of computing. And as we know, it's revolutionizing, has already revolutionized computing as we know it. That brings us to where we are right now. We're at the cusp of revolution where internet is changing from centralized monolithic services, moving into decentralized, transparent, blockchain-based, democratized services. So at this point, I think there are multiple really good projects revolutionizing decentralized compute. Ethereum, for example, has revolutionized small-scale general-purpose compute. And we at Videocoin want to do this the same thing to video. Why video? Video is actually 80% of the current internet traffic. So if you've internet on any day, 80% of all traffic that flows through the internet is video. Like all the OTT traffic, Netflix, YouTube, Hulu, they cover 80% of the traffic. Compare that with something like file sharing. It's barely 5 or 6% of it. So we want to power the world's biggest ecosystem and move it into the decentralized future. In order to do this, we've come up with a new blockchain powered by a native protocol token, which we also call Videocoin. And Videocoin by itself provides a full stack video infrastructure for you to build next generation video applications. So in order to do this, we have 3 main functions on the protocol, which is encoding, storage, and distribution. So if you look at video and files, the main distinction between video and files is a video that you watch on your TV or on your phone is completely different from each other because they're like different bandwidth requirements, different compute requirements, codec requirements, different resolution requirements. So the only way to do video properly is to re-encode video to match the device's requirements and make sure that you watch that video on the device that you have currently. So in order to power that, you need a compute engine. And we have a high-performance distributed compute built in our blockchain, which is powered by a new proof-of-stake model and a new proof of work, which we call proof of transcoding. So transcoding is, again, a process that goes and looks into the video. So all videos are encoded using something called as codecs. So proof of transcoding actually goes on a video, does a transformation on it, and then theoretically proves that you actually worked on the video to prove that the codec transformation actually maps back to the API call that was made in the video infrastructure. Again, this is like discussed in great depth in our white paper, but that's the quick summary of how proof of transcoding works. Again, this proof of work is a useful proof of work. It's not arbitrary reverse hash calculations. And one other really good thing about of video is, let's say you want to be a Bitcoin miner, right? Like the only way to do it right now, you have to install advanced ASIC ICs on your computer, and then be at a hash rate which is unimaginable for a CPU to do. But the good thing about video is all CPUs, all GPUs, all mobile phones have a specific fixed function video decoder and encoder on chip. And that's because CPUs have traditionally not been able to deal with video. And then to solve that, Intel actually introduced a hardware fixed function pipe in their standard bridge processors that came about in 2006. So ever since, every computer chip, all of them have fixed function video pipes. So the useful proof of work uses the hardware GPU functionality to establish actual proof. Yeah, and then in order to, that's at a high-level overview of our technology, and then a high-level overview of our team itself. So I'm the CTO. I'm here. I've been doing video for 10 years. I did at Intel Transcode Service, which was spun off and sold to Facebook. And then our CEO is Halsey Miner. He's been around the block for a long time. He actually did CNET back in the 90s. He was a founder. After that, he did Salesforce. After that, he did Google Voice. Like most of us here use Google Voice. And then he did OpenDNS. And then most recently, he also founded this company called Uphold. Most of us here might have heard of it. It's a Coinbase competitor with the same kind of banking technology attached to it. And then after that, we also have Seth Shapiro, who's as our head of strategy. He's a 2-time Emmy Award winner. And he's our main liaison to all the Hollywood studios and people who will, in the future, use our network. So if you look at Videocoin, right, like we're building the technology, we need, once we have the blockchain and infrastructure functional, we need both consumers and producers around this. So for the consumers who will use the blockchain to do, who will use the network to do video encoding and distribution, we're working with people like Fox, DirecTV, so we have the CTO of Fox as an advisor. He's super excited about the project. The reason is it not only cuts costs for them at a dramatic level, but also it paves way for innovation that they have not seen in the past in video infrastructure until now. On top of Hanno Base, who's the CTO of Fox, we also have the effective CTO of DirecTV as an advisor as well. So we are right now in our private sale round. We have some of the really big funds of the industry participating in us right now. So we have Alphabet, Galaxy, DNA, which is Brock's fund. They're all participating in us, and we're doing pretty well in our private round. You can get more information on videocoin.io, and anybody who's interested to talk about our private sale round, we have Kellum, who's in the audience somewhere here. You can send him a note at kellum.videocoin. Sorry, at liveplanet.net. Thank you.